Welcome back. I'm Xavier Smith, and today we are going to do some complex logarithmic equations. So we are going to evaluate log base 3 of 1 over 27. So what does this mean? This means 3 to what power equals 1 over 27. Well, if we have to flip it to a fraction, we know that this little question mark here is going to be a negative. So we could automatically just do 1 over 3, like question mark, equals 1 over 27. But we just know whatever this question mark is, it's going to be negative. So 3 goes to 27. 3 to what power is 27? Well, 3 to the third is 27. 3, 9, 27. So that means question mark, that is not a good question mark, equals -3, since it's 3 here and it has to flip. So if we just did 3 to the -3, that goes to 1 over 3 to the third, and then that is 1 over 27. So our answer is -3. Do not add that question mark in there. That's just a little placeholder. Okay, so next we're going to simplify an equation. And what equation are we simplifying? Well, log 2 of 4 to the x. How do we do this? There's two ways, and I'll show you both of them. Well, two ways I know of. So the first one is just canceling the log. So what is 4? Well, 4 is 2 squared. So we put this 2 up with the x, and then you just cancel the logs and bring down to 2x. That's pretty janky, but the other way we can do it is by using this power property and bringing this x to the front, saying x log 2 of 4. So 2 to what power equals 4? Well, 2 squared equals 4. So the question mark would equal 2. So it would go x times 2, because this simplifies to 2. So x times 2, which is 2x. So either way you like, you could get a base and the base of this exponent the same as this log base, simplify, or you could bring the x down and then simplify the log base and whatever this number is here. Moving on, we're going to solve an equation now for x. So solve log base 4 of x plus log base 4 of x plus 6 equals 2. So what do we do here? Well, the multiplication property is saying that if we have the same base here, by adding these two numbers, these two logs of the same base, you're really multiplying them. So you're multiplying whatever this number is and this number. So we can simplify this to log base 4 of x times x squared plus 6. X times x plus 6 is x squared plus 6x. So log base 4 of x squared plus 6x equals 2. Now what? Well, you could raise both of these to the base of 4. So these become the exponents of 4. So base 4, base 4. Why do we do this? Well, we want to get rid of this log base 4. So we turn this to an exponential and put it to the base of 4. So we just cancel those and then bring down this x squared plus 6x equals, what's 4 squared? 16. So 16. Then we move the 16 to the other side. X squared plus 6x minus 16 equals 0. And this is factorable, which is x plus 8 times x minus 2. So this equals 0. Now if we use the zero product property, x equals -8 and 2. But in this equation, we can't just end here. There is an asymptote in the x. So some answers are extraneous. If we try this -8 here, log base 4 of -8. You just can't have that. -8 is not an answer because there's an asymptote at the y-axis. So if I give a little drawing here, here is our y-axis, and this is an asymptote. This is what the graph looks like, and you're expecting a number out here. That's not a thing. This just goes down to an infinity and never touches this y-axis. So this -8 is not an answer. 2 is, of course, an answer. It's somewhere over here. So our x equals 2 is our answer. Just make sure when it's logarithms, you can have extraneous solutions. When it is exponential, you're most likely not going to have an extraneous solution. Well, at least an x extraneous solution, because your asymptote is in the y's and your domain is all real numbers. So now we are finding the inverse of y equals log base 4 of x minus 1 plus 3. What do? Well, we switch x and y. So x equals log base 4 of y minus 1 plus 3. Now what? Move the 3 over. So x minus 3 equals log base 4 of y minus 1. Now what? Well, exactly what we did in that other equation. To get rid of this log base 4, we put an exponential base of 4 to both sides. So now these cross off, and now we have 4 to the x minus 3 power equals y minus 1. This y minus 1 just drops down. So now we move this -1 over. So now it is y equals 4 to the x minus 3 plus 1 is our equation. And you'll know if you did it correct, because if you have a logarithm, you'll get an exponential. Just make sure all your work here is, I don't know, correct. It's pretty tedious stuff. Sometimes I mess up a lot in algebra by just doing simple addition mistakes. So just check your work. Now we are going to expand. Expand what? Well, expand log base 2 of 3x squared over 4y. Well, you have to know your properties of logarithms here, because those come into play. So what is the log base 2 of 3x squared divided by 4y? Well, it's log 2 of 3x squared minus log base 2 of 4y. So 1 log of one base minus a log of the same base is those two divided by each other. So we just do the inverse of that. Now, that's not it. We have to now expand this 3x squared and this 4y. So what do? Well, 3x squared in a logarithm is the same thing as log 3 plus log x squared, because that is our multiplication property. This is why you really have to know your properties. So log base 2 of 3 plus log base 2 of x squared minus log 2 of 4 minus log 2 of y. It's minus minus because these are both going to be in the denominator. So now what? Well, I see a couple things here we can simplify. We can simplify this log base 2 to the x squared, well, of x squared, and this log 2 of 4. So let's just do log base 2 of 3 plus, now what do? We use the power property and we move this 2 to the front, plus 2 log base 2 of x minus, what's log 2 of 4? 2 to what power equals 4? 2 to the second power equals 4, so 2 squared equals 4. So minus 2 minus log 2 of y. And I guess if it helps you, you could like put this in parentheses. You're like, oh, adding, but you're subtracting. If that helps you, remember it's in the denominator. So that is how we just expanded. We used our properties of logarithms. Now we are going to condense an equation, and this will be the last thing we are doing in this video today. So condense. What are we condensing? Log base 5 of 4 plus 2 log base 5 of x minus 3 log base 5 of x. So how are we going to condense this? Well, first we know there's a denominator here. So our multiplication property says that 2 logs with the same base are going to be multiplied by each other. But we can't just multiply this with the 2 out front. You're going to have to move this 2 back. The exponent is the inverse of the power property. So this will be log base 5 of 4 times x squared. What's 4 times x squared? It's just 4x squared. So log base 5 of 4x squared. Then minus, what's in our denominator? Minus 3 log base 5 of x. Well, this 3, we're not going to leave that there. Just like we did with this 2, we're going to just move this to the exponent. Just because we're just getting it as small as possible. So now it's over, because this is a minus sign here. Minus, so it's over log base 5 of x cubed. Well, now what? I see x's here. That can be simplified. So this x squared and this x cubed, well, this x squared, we're going to cancel that, subtract it. You could just move it down here, x minus 2, and x to the third times x minus 2 is just x. We're going to be left with x. So log base 5 of 4 over log base 5 of x. And since these are the same log, like both the numerator and denominator are of the same log, we are just going to take this log and move it outside. So log base 5 of 4 over x. So that is how we condense, we simplify, we expand, we solve, evaluate. It is a ton of things. But thank you for watching, and please subscribe and show this to your friends if they're struggling. Thank you. I hope I helped.